With X509 certificates, a certificate authority CA of an X509 PKI assigns a cryptographic public key to an end entity. Moreover, these certificates are valid only for a specific period of time, and as such, the validity of the public key is also limited to a certain time frame. Each certificate is signed by the CA with a cryptographic digital signature that is part of the certificate, and all the information contained in a certificate is ought to not be sensitive, and as such, these certificates can and very likely should be made public in order for peers to be able to retrieve the assigned public keys. If the issuing CA is trusted, meaning that the binding of the public key to the end entity is accurate, and by successfully verifying the cryptographic digital signature on the certificate, the public key contained in the certificate can be deemed authentic and can then be used for cryptographic purposes. From the general idea of certificates presented on the previous slide, we can actually deduct a first set of core elements making up these X509 certificates. As with such an X509 certificate, a CA assigns a public key to an end entity for a certain period. It's clear that the certificate must contain at least the following 5 elements. The certificate has to list the end entity that gets the public key assigned, and the identifying information of this end entity is listed in a field called subject. As it's important to know which CA issued the certificates contain a field called issuer, listing the identifying information of the issuer of the certificate. The certificates issued are only issued for a certain time frame, so the certificates contain a validity period field indicating the time window within which the certificate is valid. As we will see later, certificates can be revoked earlier than before the end of the indicated validity period, and as such, the validity period has to be considered as the maximum time frame within which the certificate can be considered valid. Then, very clearly, the certificates need to contain the public key of the subject with additionally some information about what type of cryptographic public key this key is. So for example, an RSA key or an elliptic curve key. And then absolutely essential as well is that each certificate is signed with a cryptographic digital signature created by the issuing CA, which serves the purpose that the certificate can be validated for authenticity by anyone later making use of it. All the discussions of certificates and fields of the certificates so far are still on an abstract level, but rest assured that once we get into the construction of a PKI in the following chapter, we will spend quite some time looking at actual X509 certificates and will have an in-depth discussion of all the fields and elements that we will get to see. But so far, I would like to keep the discussion on an abstract level, as it helps us to stay focused on the essentials and not to get too distracted by the very condensed information contained in actual X509 certificates. Having now the first basic idea on how these X509 certificates look like, let's have a look at how these X509 certificates are created. We know from the conceptual discussion of X509 PKIs earlier on that the requests sent by the end entities for a certificate are sent to the registration authorities, whose task is to conduct the identification of the requesting end entities, and that once these registration authorities successfully validate the identity of the requesting end entity, the request for the creation of a certificate is forwarded from the registration authority to the certificate authority CA. The information that the CA receives is the identifying information about the subject that then will have to be listed in the subject field of the certificate, and the CA, of course, also has to be provisioned with the public key of the subject. Based on this information, The CA can then create a draft of this certificate content with all the necessary information contained in it, and the only thing missing is the cryptographic digital signature. Creating this cryptographic digital signature is then really just the cryptographic digital signature process as we got to know in the essential cryptography chapter at the beginning of this course, where we got to understand that cryptographic digital signatures are created by making use of cryptographic private keys. The digital signature on the certificate is thus created by the CA by having the CA make use of its own cryptographic private digital signature key, and with this key signing the draft of the certificate content, which results simply in a plain digital signature. This digital signature is then added as the last field to the certificate, which completes the certificate, and with the CA then pushing this certificate into the public registry of certificates to make it publicly available. This process of creating X509 certificates is of absolute importance to later on understand the trust model of PKIs, so I invite everyone to please take your time and to try to make sure to really understand this certificate creation process. This is already quite a big step into understanding the workings of X509 PKIs, but we nevertheless still have a couple of questions about the creation of certificates left to answer in a later session. Our first question we have left to answer is how exactly is the content of the certificate technically presented to the registration authorities and the CAs? Who creates the public-private key pairs of the end entities? Is it the end entities or is it the CA? And also, what validation is really required by the registration authorities before the request of an end entity for a certificate can be granted? Let's now get a first understanding of what is involved in the validation of a certificate that needs to be conducted by an end entity before the certificate and the cryptographic public key contained in the certificate can really be used to secure the data. Ignoring details discussed in a later chapter, validating the so far 5 fields contained in an X509 certificate amounts to basically just validating each of these 5 fields. Validating the subject means to validate that the information contained in the subject field really identifies the end entity that one wants to communicate with. Validating the issuer means that the issuer of the certificate must be a CA that one trusts to issue accurate certificates. The validity period indicates the maximum time period within which the certificate is considered valid. So validating this field means that the current time of usage of the certificate lies within the validity period specified on the certificate. If the current time of usage lies within the specified validity period, then verifying the validity of the certificate involves a second additional step, namely to check the actual status of the certificate with the CA, as a CA can revoke a certificate at any point for various reasons, such as having made a mistake in the identification of the subject, or having reasons to believe that the private key of the end entity was leaked, or having reasons to believe that the end entity violated any codes of conduct, and so forth. The status of the certificate can be requested by multiple means, where a first popular mean to check for the current status of a certificate is by making use of certificate revocation lists maintained by the CA, which really is just a list of revoked certificates signed by the CA. A second popular mean to check for the current status of a certificate is the Online Certificate Status Protocol OCSP, which is a simple protocol with which the revocation status of a specific certificate can be requested from the CA and where the CA responds with a status of either good or revoked. The X509 PKI we will construct and put to use later during this course will be equipped with OCSP responders, so stay tuned to soon see OCSP in action. Last field to validate is then the digital signature contained in the certificate. We know that the digital signature must have been created with the private key of the CA listed as issuer and is a signature across the content of the certificate from the beginning of the certificate up until the signature, but excluding the signature. The validation of this signature is then the cryptographic digital signature verification mechanism over the content of the certificate and against the public digital signature verification key of the CA listed as issuer, and if this digital signature successfully verifies, then the certificate can be deemed authentic and indeed to have been issued by the CA listed as issuer. There are two questions we have left to answer at this point. The first question is, how is the public digital signature verification key of the CA distributed to the end entities such that the end entities can indeed verify the digital signatures on the certificates? And the second question arises from the observation that the private signing key of the CA seems to be an extremely valuable key, as the validation of each certificate relies on this key to really only being available to the CA and no one else in order to prevent from wrong certificates to being issued. With this observation that the private key of a CA is extremely valuable, the question then really is on whether the activity of this private key can be reduced, as currently the private signing key of the CA is required to sign each and every certificate to be issued, but with each usage of the private key, the risk of this key to be misused or to be leaked actually being increased. This is the end of this lesson, and I invite you to try to think of an answer to this second question yourself before going into the next lesson, where we will see how X509 PKIs manage to solve this challenge.